Okay, our group is doing a car park indicator system to show how many available lots. The 7 segment display, which is this one, will show the number of available lots. Then the LED lights will show whether the lots are empty or not. If the lights are on, meaning the lot is available. If the light is off, meaning the lot is occupied. Then this one is our reset button. This one is the input signal button. Then this one is the switch, which detect whether the car is leaving or entering.
Okay, this is when the lots are not filled with cars. Okay, now we are going to show you how what happens when the cars comes in. This is when there's a car, when the cars goes in the gantry, and the LED shows one of the LED lights off, and the 7-segment display shows 7 available lots left. And this is 6, 5, 4, 3, 2, 1. And when it's when there's no lights, that means the car park is already full, so it shows F over here. Okay, now I'm gonna show you when the car starts leaving the car park. So it goes 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, and the reset button is used to show the display of the latest status of free slots. So when I press the reset button here, it will show you the latest slot. Sorry. Okay. Yeah, thank you.
This is our block diagram for our car park indicator system. There will be 3 different VHDL coding for our system, namely the counter to count the number of cars that will be entering or leaving the car park, the 7-segment display to show the number of available lots, and the LED display to also show how many lots are occupied or free. For the VHDL program for the counter, there will be a port for a sensor which sends whether the car is entering or leaving the car park, clock to count the number of cars, reset which resets to the latest number of lots available, and Q which will send a binary input to the decoder to be displayed on the 7-segment display and the LED display. We would need 8 bits to accommodate the number of inputs that we need, therefore requires a vector of 3 down to 0 to allow us to have 15 bits with 7 bits remaining unused. After every port needed is declared in the entity statement, the architecture flow will run. Count signal is declared to use as a base for our counter. When reset is activated, the latest count signal will be assigned to the count signal to be updated. If the sensor detects a car leaving, the counter will be a count up program to increase the available lots for every car that leaves the car park. Else, if it senses a car entering, counter will be a countdown program and decrease the number of lots available for every car that enters. The program will end its process and flow after all conditions are met. The car park 7-segment display is programmed like a decoder. 7 bits binary will be the settings for the required output to be displayed on the 7-segment display, and it is assigned to a 4-bit binary which is an input from the counter program. Since there will be 7 remaining bits unused, as we only require 8 bits out of the 15, we have assigned the remaining to be displaying that the car park is full. Then the output vector is to be separated to make individual pin outputs. Then after it has run the statements, architecture will end. The LED display program is designed to also show in a different way how many lots are available or occupied. Ports are declared for inputs and outputs of the program. As the architecture runs, signal input of 4 bits and signal output of 8 bits. As architecture runs, signal input of 4 bits and signal output of 8 bits are declared for the LED display program. Every 4 bits binary input from the counter is assigned to the 8 bits binary settings for the LED display to sync with the number of available slots of the car park. The remaining 7 bits that are also unused will be assigned to as full. Therefore, no LED will be on to show that there is no available slots in the car park.
This is our vector waveform for our car park indicating system. The sensor represents the car entering or exiting the car park. The clock represents the number of cars that goes in or out of the car park. Reset represents the latest slots available when it is pressed. Q is the input of the 7-segment display and will display numbers on the board. If the sensor is low, the car is leaving, thus increasing the slots available until 8. So it will be from 0 or F, 1, 2, 3, 4, 5, 6, 7 and 8 slots left. If the sensor is high, the car is entering the car park, thus taking up the slots from 8, 7, 6, 5, 4, 3, 2, 1, 0 or F.